Hello everyone. So today we are going to do Leetcode contest question, node with highest edge score. So basically in this question, we are given with a particular edges array, and after that we are given with, or in this edges array, how it is being represented. So first let's read out the question, that how is it that first you are given with a directed graph with n nodes labeled from 0 to n minus 1. So this particular edges array is basically zero based indexing, where each node exactly has one outgoing edge, and a graph is represented by zero index integer array edges of length n. Edges of I indicate that there is a directed edge from node I to node edge of I. So that basically is the main point which we need to capture. The thing is that at this particular zeroth index, it simply represents that it is basically pointing towards the 1, but it's other way around. The thing is that at 0 index, the edge which is being mentioned there, so the thing is that we are required to go to that edge 1, and then as it is on the 0th index, so we are required to connect that particular with 0. So, and that 0 would be the edge score for this one, and this is all about this question. So all these values which are being given in this particular edges array is all about the edges which are being given to us, and the indices which are corresponding to this particular, it simply represents the edge score of that particular, and so we are required to return the maximum edge score. So if we take this first example itself, then how it is like that in this one, that is the value, and it is at the index 0, right? So that's why it is basically having the edge score 0, and then when we are having this 0, then 0 means 4 zeros which are there, so it is corresponding to 1, then 2, then 3, and then 4 indices, right? So that's why the edge score for this 0 would be 2 plus 3 plus 4 plus 5, which is being written in this first point itself, right? So now comes the part for this particular 7. So 7 is basically at the index 5 and at the index 6. So the edge score of the same is 5 and 6. Basically, here it is written that nodes 5 and 6 have an edge pointing to 7. So that particular node is being given to us, means the indices which are given to us, which is corresponding to this particular node. So we are returning the edge score, which is basically sum of the nodes, and those nodes are the indices which are being given to us, that is 5 and 6, and thus the edge score for the 7 is 11. And here this is the highest edge score than this particular, so that's why our answer is basically 7. So this is the whole crux of this question which we are required to return. So in all that context only, how I came up with the solution was, first I directly run a brute force solution. I thought that I should store it somewhere in pair form, and then after that just sort it and then return the highest value. And in this thing also there is one more case mentioned, that return the node with the highest score. This is the first thing which we are required to do. And the next thing is that if multiple nodes have the same edge score, then at that particular moment we are required to return the smallest index. So here I encountered one case, actually I just ran the one directly, but then I got wrong answer in one case, and that case was that both of them were having the same edge score. Actually that case was, I was getting this particular, means the that was this one, 0, then 0, and then it was 1. So now here you can see that 0 is corresponding to 3 and 1 is also corresponding to 3. So my answer was returning 1. So, but the answer should be 0 here, because 0 is that 1 which comes at the first from the 1, right? So that's why here I got the wrong answer and the 0 was my answer. So now you can think about how you are required to solve this question is by just think that in what you are going to store and how you are going to either sort it or compare them with each other so that you could return the highest value. In that sense you can do. means you are not even required to make a graph. But I will show you both of the solutions with graph also and without graph also, and even the brute force one. So here's the brute force solution. That how I did at the first moment was I took an unordered map, and why long is required, because of the fact that here we are required to sum up, and it sum could go to such an extent that it will show us that it has exceeded the integer, means it can't be stored in int. And then this is for the purpose of storing the final answers, basically edge, and there's edge score. For that purpose I'm storing here. So now here what I'm doing is I'm directly first storing all the edges with their edge score, and then I have extracted all those edges with their edge score into this vector. And why I did that, so that I could directly sort them with this comparator. So this is comparator which I make, and this is that condition on which I got the wrong answer, that when both of these edge scores are equal, then we are required to return that particular edge which is having the less value, that is we are required to return 0 rather than 1, and at the end we are required to return with the highest edge score only if above is not the case. So now comes the next part, that after it is sorted, so now what should be the answer? So our answer will be stored at the first position because we are sorting it in descending order, right? So that's why at the end we will be returning our answer is this manner. Now comes the more optimized version of this particular solution, because you can yourself see that this makes it n log n solution, right? But this particular could be done without doing n log n, and even the time complexity of this particular is order of n. So that's why we are required to optimize this particular solution. But it is much good that you should know that what the brute force approach was being used here. So that's why I have put both of the solutions, else I would have removed this particular solution, that what I was using at the starting. Now comes the next part, that is more optimized version of the above, and this version is basically the one which uses time complexity as order of n only. Earlier we were sorting that, and that's why our time complexity increased. But here it is all in order of n only, and here again we are using this particular vector, so that's why our space complexity here becomes order of n itself. So now comes the part that how we are required to do, and all these things are without using graph. So what we are doing is we have now eradicated the part of that unordered map, and now we are just using the vector. And in this vector only we are just storing the edge scores, right, and edge scores with the corresponding edge. And now we are required to check for what is the maximum here. So this particular portion has eradicated the part of that comparison, means that bool comparator which we were using. And now comes the part that we will be comparing each edge which is being stored in our scores, right? And then we will check that at that particular edge what is the value which is being there. If it is greater than max, then we'll update the max with that particular, and we'll update the index, right? Because at the end ultimately we are required to return the index, basically that edge, not the edge score. We are just comparing on the basis of edge score, right? So at the end we will return this edge score. Now comes the next part, that we can also do this particular by using a graph. Although this doesn't came to my mind at that particular moment of time, but then somehow I just wanted to try that how we can do this particular with a graph. So then just I checked that how it could be done, and then it's again that we are required to store it in a particular thing, and now we are storing it here. And then after storing this particular here, what we are doing next is that we are making a particular graph, an undirected graph. That's what we are making here. And then what we are doing is we are just storing our result node into this particular, and the best scores into this. That's why we have initialized the 0. Now comes the part that we are required to compare and store all of them. So here comes the part that we are storing that, and how we are storing it. We are first taking that each node from that graph of I, and then we are directly adding up that particular nodes. These are those nodes which were being written here like this, means these nodes which are being added, and so that are basically contributing to our edge score. And then we will be comparing here that what is the highest score till now, and then we will be storing that particular result node into this particular, because this is what we are required to return. Basically that index, the value which was being there corresponding to that index, that was what we were required to return, and the best score is updated here so that we could compare again, and then at the end we are returning our result node. So this was all for this particular question, and here you got that how with graph and how without graph we could do this question, because it was directly on the basis of then brute force and then some optimization, so we came to our solution. So this was all for this. So thank you.